In the movie Angels and Demons, a single canister of a mysterious substance is stolen from a lab threatening to destroy the Vatican. It sounds like pure Hollywood fiction, but the physics behind it is terrifyingly real. The substance is antimatter. It is the only material in the universe that converts mass into energy with 100% efficiency. To put that in perspective, a nuclear weapon converts only about 1% of its mass into energy. If you held just 1 gram of antimatter in your hand, about the weight of a paperclip, and it touched your skin, the resulting explosion would be equal to the atomic bomb dropped on Hiroshima. It is the most volatile, dangerous, and powerful substance in existence. So what is it? Is it some kind of exotic alien magic? No. It is actually quite simple. Antimatter is the evil twin of normal matter. For every fundamental particle that makes up you and me, there's a mirror version. It has the exact same mass, but the opposite electrical charge. Take the electron. It is negatively charged. Its mirror twin is the positron. It has the same weight, but a positive charge. Take the proton. It is positive. Its mirror twin is the antiproton. It is negative. If you built a car out of antimatter, it would look and drive exactly like a normal car, but you could never touch the door handle. We discovered this ghost world through mathematics before we ever saw it. In 1928, a British physicist named Paul Dirac was writing an equation to describe how electrons behave at high speeds. When he solved the equation, he ran into a problem. Just like the square root of 4 can be 2 or 2, his equation had 2 solutions. One described a negative electron, the other described a positive electron. Most physicists would have ignored the second answer as a math error, but Dirac didn't. He boldly predicted that the universe must contain anti-electrons. 4 years later, the ghost appeared. In 1932, American physicist Carl Anderson was studying cosmic rays using a cloud chamber. He saw a track that looked exactly like an electron, but it curved in the wrong direction under a magnetic field. Physics said it had to be positive. He had found Dirac's anti-electron. He named it the positron. For the first time, we realized that our universe has a shadow side. This discovery brought a terrifying realization. Matter and antimatter cannot coexist. If you take 2 rocks and smash them together, you get dust. But if you take a rock of matter and a rock of antimatter and touch them together, they don't break. They annihilate. Because they are opposites, they cancel each other out of existence. The physical mass completely vanishes. In its place, the mass is converted instantly into pure energy gamma rays, following Einstein's famous equation EMMC2. To understand the danger we have to look at the efficiency. A modern nuclear weapon is frightening, but it is actually very inefficient. It converts less than 1% of its fuel into energy. Antimatter converts 100%. Let's do the math. If you took a paperclip made of antimatter weighing roughly 1 gram and touched it to a paperclip made of normal matter, the resulting annihilation would release 43 kilotons of TNT equivalent energy. That is 3 times powerful than the bomb dropped on Hiroshima. A single paperclip could flatten the entire downtown area of a major city. Because of this power, you might wonder, why haven't we built antimatter power plants? Because it is impossible to find. There are no antimatter mines. We have to create it, atom by atom. The energy required to create antimatter is billions of times higher than the energy we get back from it. According to NASA, the cost to produce just 1 gram of antihydrogen is approximately $62.5 trillion. It is by far the most expensive substance in the history of mankind. So where do we make it? The main factory is at CERN in Geneva. They use the antiproton decelerator. First, they smash protons into a metal block at nearly the speed of light. The energy of the collision condenses into new particles, including a few antiprotons. But these antiprotons are moving too fast to catch. They have to use magnetic fields to slow them down, to cool them so they can be trapped. Once you have created it, you face the ultimate problem. How do you store a substance that destroys anything it touches? We use a pinning trap. This is a device that uses strong magnetic and electric fields to suspend the charged particles in a perfect vacuum. The antimatter floats in the center of the trap, levitating, never touching the walls. If the power fails, or if a single molecule of air leaks in, poof, the containment breaches and the antimatter annihilates instantly. But you don't need to go to CERN to find antimatter. You just need to go to the grocery store. Believe it or not, bananas are antimatter generators. Bananas are rich in potassium. A small fraction of that is potassium-40, a radioactive isotope. Every 75 minutes or so, a banana will naturally decay and emit a single positron. That positron flies out, hits an electron in the air, and annihilates. So while you eat your breakfast, you are holding a tiny biological particle accelerator in your hand. It isn't just bananas. The source is closer to home. Your body contains potassium, salt, and carbon. Because of this, you are technically a low-level radioactive source. A human body of average size contains enough potassium-40 to emit roughly 180 positrons every hour. That means about 3 times every minute, your body creates a particle of antimatter. You are a walking, breathing biological reactor, destroying yourself atom by atom millions of times a day. We have even learned to harness this destruction to save lives. If you have ever heard of a PET scan to detect cancer, you are using antimatter technology. Doctors inject a tracer into your bloodstream that emits positrons. When those positrons annihilate with electrons in your body, they release gamma rays. The scanner detects those gamma rays to map your insides with incredible precision. We use the most dangerous substance in the universe to find tumors and cure diseases. But this brings us to the biggest mystery in all of physics. According to the standard model, the laws of physics are symmetrical. When energy converts to mass, like in the Big Bang, it must create equal amounts of matter and antimatter. Matter and antimatter are always created in pairs. So at the beginning of time, the universe should have been perfectly balanced. 50% matter, 50% antimatter. And that is the problem. If the universe was created with a 50-50 split, none of us should be here. In the dense heat of the early universe, all that matter and antimatter should have mixed together. They should have annihilated each other instantly. The result should have been a universe filled with nothing but light and radiation. No atoms, no stars, no galaxies, no life. But we are here. Why? Because nature is imperfect. Physicists believe that for some unknown reason, the symmetry broke. For every 1 billion particles of antimatter created, the universe created 1,001 particles of matter. The billion pairs annihilated each other and filled the universe with light. But that one extra particle of matter, it had nothing to kill it. It survived. Every star, every planet, and every atom in your body is made of those tiny leftovers from the Great Annihilation. If the antimatter wasn't destroyed, where is it? Some physicists have proposed that perhaps the universe separated. Maybe there are entire regions of space made of antimatter. Imagine an anti-galaxy. It would have anti-stars burning anti-hydrogen. It would have anti-planets orbiting them. But if an astronaut ever landed on an anti-planet and took off his helmet to smell the air, the moment his breath touched the atmosphere, he would trigger a nuclear explosion. However, astronomers are fairly certain these anti-galaxies don't exist. The evidence lies in the space between. If there were regions of matter and regions of antimatter, they would touch at the borders. That border would be a zone of constant annihilation. We would see a distinct wall of gamma radiation stretching across the sky. But when we look at the universe with gamma-ray telescopes, we see darkness. This suggests the leftover theory is correct. The antimatter is truly gone. While we can't find it in nature, we still dream of making it. Why? Because it is the key to the stars. An antimatter engine would be millions of times more efficient than liquid hydrogen. With an antimatter drive, we could accelerate a ship to 50% the speed of light. A trip to Mars would take weeks, not months. A trip to Alpha Centauri, which would take a normal rocket 70,000 years, could be done in just a few decades. It is the only technology that puts the galaxy within human reach. But don't pack your bags yet. The technology is centuries away. To hold enough antimatter for a trip to Mars, just a few milligrams, you would need massive heavy superconducting magnets to keep it suspended. And it is dangerous. If the magnetic field flickered for even a microsecond, the fuel would touch the tank wall. The ship wouldn't just break. It would vaporize in a blast brighter than the sun. Antimatter is a reminder of how fragile our reality is. It is the most expensive explosive and elusive substance in existence. But it is also the reason we are here. If the universe had been perfect, if it had created equal parts matter and antimatter, we would not exist. There would be only light. We are the survivors of a cosmic coin toss. We are the 0.00001% of matter that survived the fire. Our entire existence is a lucky accident, a statistical error in the math of creation.